We stopped at discrete numbers, right?
Yes.
All right, so I said that under the numbers we have discrete numbers, we have continuous numbers. I was trying to explain what discrete numbers are, right?
Yes.
So these discrete numbers, I say that they are distinct. Okay, you can easily identify them, count them, or whatever. They are what discrete. Okay, they are distinct. Now, one thing there is that if you look at the if you look at the if you look at the if you look at
Number line.
the number line now, these numbers you are seeing are what? Discrete what? Numbers. There are also some numbers inside that are discrete, okay? Now, but the basic thing I want you to understand is that these numbers start at a point. It stops at a point. This is where it stops. Am I communicating? But there's a numbers you can't even say know where they stop. If you say 0.5, 0.5, 0.5, am I communicating? If you say 0.5, is half is what? Half. You can get half again, half again. Half is what? Half. You can get quarter. 1/4, right? Quarter of something. Quarter. Get quarter of it. True or false? Good. You can get 1, 2, 3. Keep getting to 4, 5, 6 to 20. But numbers like 0.0666666666 is not stopping anywhere. That number never stops. It can never stop. Those ones are continuous. It's non-stop. So in between here now you see, okay, 0.33. Where will it stop? Unless you approximate it. See how that stop. You approximate it, and it cannot stop. You only did what? Approximated it. Simple. It doesn't stop. These type of numbers are what? They are what? Continuous. Am I communicating? Am I communicating? What's that? Okay, forget what I said. What do you understand from what I said? I think that you know what you say to put it down is different from your understanding of it.
Yes.
Are they the same thing?
Yes.
So let's start from what did you understand from what I said. Let's start from there. Yes, and continue. Just make one statement. If you made a statement, I will know whether you understood what I said about them. See, please fight for understanding. It's not about putting down your notes. No, putting down notes is important, but fight for what? So tell me, let's hear from you what you understood. What you understood what I said, okay?
Discrete number.
Mm-hmm.
Yeah, easily counted and identified.
Okay.
Like minus 6, minus 5.
1, 2, 3, 0.5.
0.5. Then I didn't get that one.
Continuous. Continuous is unending. They don't end. Here now, where will you call? Hope you know that. Are you aware that here can be 5, right? And here can be 4. You can actually have minus 5.5 here. True or false? But where will you call 5.3333? Is what? Continuous.
Yes.
Am I communicating?
Yes.
Am I communicating? Yes. Now, see, I'm just explaining this at this. There are deeper. If I start going deep, there are things I wouldn't want to start going into. But the point there is I just understand this at this level. Am I communicating?
Yes.
Now, this will now lead us to some numbers. Some of them inside one, you can see some of them that are discrete. Some of them that are what? Continuous. You see numbers like integers. All these things are under what? Real numbers. We have integers. We have natural numbers. We have whole numbers, right? We have rational and what? Irrational numbers. We have integers, we have natural numbers, we have whole numbers, we have rational, we have irrational. So I'll use this. Huh?
It's under real.
I say, listen. I say this is what real numbers. In terms of being distinct, you can easily count it or measure it or having an ending, have that it can end at a particular point. We have, in terms of that, we have discrete and what? Continuous. Even for names, say we should know this is continuous. It doesn't stop. And I give examples: 0.0, 0.66, 0.0. You cannot. You would even know how where should be 0.3333. In fact, 0.33 can never stop. True of us. Number like pi, 22/7. Can it stop? If you don't worry, by the time we go into this number, you find out that pi and 22/7 are not the same thing. Pi is not 22/7. Are you aware? But you are told in such so that it is 22/7. I will explain. Don't worry, we'll get there. Now you start seeing 3.144, blah 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 till infinity. It does not end. It's a continuous number. Am I communicating? Am I communicating? Am I? Are you sure I'm communicating? Good. Now, there are some continuous numbers that are rational. Have you seen why I still want to talk about these numbers? Based on your question, there are some continuous numbers here that are rational, and there are discrete numbers that are also what? Rational. Okay? Okay, that's why you cannot group this under particular. This is a different classification method. Why this one different what? Classification what? System of numbers under what? Real numbers. Am I communicating? So we have integers, natural numbers, whole numbers, rational and irrational. I'll use this number line to explain this. Now, what are integers? Remember, real numbers. Real numbers include everything here, right? Both the ones you are seeing, the one that is hiding inside the space, and the one you are not what? And the one you are seeing. They are under what? Real numbers. Now, under the numbers, we have the first one is integer. Under the integer now, integers are those numbers in the on the what? In the real numbers. Integer under real numbers are those numbers in the number line you can easily you can do what? See and what? Identify. Things like this. This is 5, 4, minus 6, minus 5, minus 3, 0, 1, 2, 3. These are what? Integers. They are what? Integers. We have negative integers and what? Positive what? Integers. 0 is an integer, but it's neutral. Okay? 0 is neutral. It's also an what? Integer. You have positive integers. Those ones are the negative, at the negative side of the number line, and the negative what? Integers. The ones at this side are the positive what? Integers. 0 is neutral. 0 is also an integer, but it's what? Neutral. So this thing you are seeing here, they are what? Integers. The one in between, you start seeing, show you that here is 6 and 5. Any other thing here will have decimal point. True of us. They are not integers. Integers don't have what? Decimals. Okay? They don't have decimal point, even though we know that sometimes you have 4.0. Because this is 0, we can ignore it, right? And call it 4. Except in this situation. Because if you ignore it, 4 is an integer, right? But once you have 4.1, it's not an integer. Are we together? It's not an integer. It has become significant. The point there has become what? You know, here, the decimal point here is not significant because 0 can easily be what? So it's 4 is an integer, but 4.1, 4.222 is not an integer. So integers is the one can easily do what? So the space between the two successive numbers is up to 1. If the space between two successive numbers on the scale of the numbers is more than 1, you can still have integer in between. True of us. If here is 4 and here is depending on the scale you are using, and here is 6, 5 is here. True of us. Is 5 an integer? But this one now, what is between two of them is just 1. Anything less than 1 is trapped inside here. True of us. Those ones are not what? Integers. Are we together? So these are integers. Now we are from integer, we are going down now. So after integers, the next one is what? Natural numbers. So what are natural numbers? Natural numbers are integers. They are actually integers. They are integers from 0 to the positive infinity on the number line. Natural numbers are integers from 0 to positive infinity on the number line. So from 0 here, everything from 0 here, listen, look at it. Sometimes they are called counting numbers sometimes. Anything, I think I know, is, yes, they are. From here, 0, you have 0, 1, 2, 3, 4, 5. They are what? Natural numbers. Are we together? Natural, not rational. Natural numbers. So 0 is a natural number. 1 is a rational number. To positive, notice anything negative is not a natural number. Know that point, okay? Good. Is 2.1 a natural number? Who say yes? What do you say? It's not an integer now. Natural numbers are integers, but integers from 0 to post. The basic prerequisite is that number must be an integer. Okay, and I've already explained what an integer is. Okay, so natural numbers are actually integers, but not all integers are natural. It's from 0 to positive what? Infinity. Are we together? Good. Now, okay, now the next one is what? Whole numbers. From here again, what are whole numbers? Whole numbers are also integers. Are you aware? But they are integers from 1 to the positive what? Infinity on number line. So 0 is not a whole number. Are we together?
Yes, sir.
Whole numbers start from where? 1, 2, 3, 4. Minus 1 is not a whole number. Whole numbers start from where? 1, 2, 3, 4, 5 to infinity, positive infinity. These are the what? Whole numbers. Are we together? Are we together?
Yes.
Good. Now, I'm checking time so that I know when to stop. Now, the next one I want us to look at is what? Rational and irrational number. Pay attention to this place. Pay attention. They can be confusing. Pay attention. Now, we are done with 1, 2, 3. Do you know where rational came from? Come from ratio. How do you get that? Ratio, rational. Now, let me define a rational number. Put it down. A rational number is any number that can be expressed in the form A over B. A rational number is any number that can be expressed in the form A over B, where A and B are integers. Where A and B are integers. Are you confused? When I say over, we just simply write what? A over what? B. Where A and B are integers. A can be 0, but B cannot be what? 0. Remember that 0 is an integer, right? Remember, true of us is an integer. But when a number is said to be rational, if the number can be expressed in the form, of course, you know that rational numbers are fractions. Hope you know. Are you aware? Are you aware? fractions are rational. Are you aware? That's why if yet something like A is to B, certain as saying A over what? Hope you know. Are you aware? Are you aware? Don't worry, we'll get there. We'll go to ratio. I'll throw more light on it. I don't want to go into ratio now, but I want to explain something. We'll still treat ratio, okay? You understand this thing I did here, okay? Now, so just know that a rational number is a number that can be expressed in the form A over B. So that A and B are what? Integers. A can be 0, but B cannot be 0. If B becomes 0, it's not a fraction. It becomes undefined. Who did you do? Hey, can you make mathematics about? Yeah, undefined fraction. Who did it here? When did they tell you that you look at 2 over 0 is what? Undefined. Undefined. Are we together? Is what? Undefined. So A, B cannot be what? 0. Now, let us now. That means, what this means, a rational number can be an integer. Hope you know. But it can also not be an integer. Yes. 4 is a rational number. It shock you? 4 can be expressed as 4 over 1. 4 and 1, are they not integers? Are they not integers? Yeah. Is 1 0? No. 4 1 is what? 4. True of us? So 4 is a rational what? No. Numbers. Okay, you think it's only when it is fraction, then it's a rational number. No. A whole number can also be rational what? Number. So 2 is also a rational number. 2 over 1 is what? 2. True of us? Good. 0 over 1 is also rational. True of us? Yes. Now, there are rational numbers that are discrete. There are rational numbers that are say what? Continuous. Are we together? Yes. So basically, what I've said now, what am I even saying? Can't even have 4.0. Can we have such thing? Is 4.0 not 4? It's 4. So rational numbers can have decimal points. It may not have what? Decimal point. True of us? True of us? True. Good. Now, do you know where the issue lies? If a number has decimal points, how do you now know whether it is rational or irrational? That's where the issue lies now. There are numbers, not all numbers with decimal points are rational. Some are rational, some are irrational. So how do you now know the ones that are rational and the ones that are what? Irrational. Like that they told you at secondary school. Assume pi to be 20 over 7. It's not true. They give it to you at that stage. When you were in your nursery school, were you told that they said like -1? Minus plus, minus is. Were you told anything like that? But when you are coming up, you started hearing those things. True of us, that's what you are told at that level. But pi is not 20 or so. In fact, let me shock you. 20 over 7, this will give you a continuous number. And pi will also give you a continuous number. 20 over 7 is rational. But pi is irrational. 20 over 7 is rational. Pi is what? Irrational. Now let me explain. Let me go down to how to identify rational and irrational number. Basically, rational numbers can be discrete. They can be what? Continuous. Irrational numbers are always continuous. Okay? They're always what? Continuous. But not all of, and they have the decimal points. But not all of them are irrational. Some that have decimal point are rational. Now let me explain. Let me explain. Let me explain. Before I do that, there's one concept I want to bring in that will help you to understand this. There's when I told you that continuous numbers have decimal point, right? Even some discrete, you can put the decimal point. There's even some discrete have the decimal point. True of us, we have 0.5. True of us. Now let me now explain types of decimals. You're able to understand rational and irrational types of decimal. We have the one we call terminating decimal. Terminating what? Decimal. And we have the what? Recurring what? Decimals. We have terminating decimals and we have recurring decimals. Are we together? We have terminating and we have recurring decimal. Now, under recurring decimal, we have single recurring. You can call it anything. When I explain, you can tag it, you can name it anything you want to name it. If you understand it, we have single recurring and we have non-what? Single. Now, let's explain what is terminating decimal. Look up. 1/2 is what? 0. What? Is a terminating decimal. It stops at 5. Bam. True of us? True of us? Yeah. It's terminating. 6/10 is what?
0.6.
0.6 is a terminating decimal. True of us?
Yes.
Now, 1/4 is what? 0.25. 0.25 is terminating. True of us? It stops here. 1 is a terminating what? Decimal. Right? Now look at this. 1.3. 1/3 is what? 0.33333 on n is continuous. This is not a terminating decimal. It is a what? Recurring decimal. It is what? Recurring what? Decimal. Is what? Recurring decimal. Is single recurring. True of us? Is that single thread that is repeated? Are we together? Is single what? Recurring decimal. Now, do 2/7 and tell me what the answer is. Hope you know that. Okay, don't worry. Just punch it. I wanted to do it myself without calculator, but for want of time. Can someone do this without calculator here for us? All right. So call the full number. Do it as calculator. There are some that. Okay, call.
3.1428.
Wait. 3.14. Oh, I don't like this. It has appropriated it to 3 here. It not gives us what I'm looking for. Don't worry, let me do it. Let me do it without calculator. It give you what you see. What I mean by recurring, but not single recurring. Let me do it without calculator. Hope you put this one down. Yes, sir. And you understood it, right? Good. Let me divide this. I've shown you terminating decimals, right? I've shown you single recurring. And that single recurring is what? 2/3 is what? 0.666 is recurring, right? Yes, sir. That last one is an approximation because of how if you that's a calculator that can stay from here to here. If you keep going, it doesn't end. But that approximated it to 7, the last digit to 7. Okay. Now let's now do what is it called? Let's now do. Let me divide 2/7. I want to stop here. Let's get here. Let's start from here. Now listen. I'll do this now. Stop at the end of that board. last digit that entered the end of it. I will want to open up the number so you see how it runs. You tell me the type of decimal it is, okay? Now 2/7, let's go. 2/7 is what? So there are 3 sevens inside to 12, yeah? Remember one, right? You write 3. That one for that one for you multiply this everything. This thing is in base 10. We are working in what? Base 10. So that one that remains, you multiply by the base you are working on. Okay? Okay? So 22 divided by 7 is what? 3. Remember what? 1. You multiply by the base you are working on. You are working in base 10, right? So that remainder, which is 1 times 10, is what? 10. There's no other number here to add it to. You continue dividing. 10 divided, you put that in decimal point. 10 divided by 7 is what? 1. 1, right? 1 remainder what? 3. You multiply that 3 by the base you are working on. 3 times 10 is what? 30. There's nothing to add it to, right? You keep dividing. 30 divided by 7 is what? 4. You put the 4. What is remaining? 2. Multiply that 2 by 10 to give you what? 2. You keep dividing. 20 divided by 7 is what? 2 remainder what? 6. There's nothing to add again. You multiply by 10, right? 10 times 6 is 60. You keep dividing. 60 divided by 7 is what? Are you sure? 8 remainder what? 8 remainder what? Are you sure? 7 times 8 is what? Okay, you are right. 8 remainder what? 6, right? Good. Multiply again. 60 divided by 7 is what? 60 divided by 7 is what? It's not true. You gave me a wrong answer. 60 divided by 7. Let's start from here. What did we do to get this true? 20 is what? 2 minus what? 6. 6 times 60 divided by 7 is what? 6. That's where you should come. 8 what? 4. So 4 times what? Keep dividing. 5 minus what? 5. 5 times 3 is what? Keep dividing. 6 minus what? 50. What? 10, right? Keep dividing. Times 10 again. Keep dividing. 2, right? 2 times 10. Dividing. 6, right? Come down. We are coming down. I don't need so you understand what I'm saying. So what? 60 times 6 what? Good. Calm down. See. Please, let's cool down. Let's have patience. I want to do. 5. Five remainder what? 5 remainder what? 5. 7 remainder what? 1, right? 10. 1 remainder what? 3. 2 remainder. 4 remainder what? 2. 2 remainder what? 8 where? 5. Because this is what the calculator does. Because is it clear now? Now, look at this number. Is there this is 14285. 14285. 7. 14285. 7. 145, 7. It continues. This is a recurring decimal. Not single, right? Not for 5, 7, and or 3, they will change. This is very what? I get that. Conditional numbers will give you recurring decimals. If you want to know whether a continuous number is right, you ask the decimal if it's continuous. In fact, if it's a number is decimal, it will give it out. If the decimal is what? Rational. Then if it's not repressed, it's also what? Rational. But there are some continuous numbers that are not rational. You take us to those ones that will give you decimal number, but they call it what? Irrational numbers. What's that? What's your answer? That's why I told you I want you to say now. So where is here now? Basically, there are no that are not. When I say for first, that this number is continuous. And then the numbers, decimal numbers, we have the one that have terminating decimal. You stop at a point, and what the one that are not terminating, that was recurring. Okay, let me students. Okay, we have decimals. All decimals now. We have terminating. Okay, we have terminating. We also have non-terminating. Okay. I'm terminating. Then under non-terminating, then we have recurring. Okay, and what? Non-recurring. Pattern. Okay? This one they have what? Pattern. Okay. Then under recurring, we have single recurring. Okay. And what? Non-single. These things are what? Are what? Decimal, right? You understood this, right? That we have terminating decimal and what? Terminating. That's the issue now. People that say that they don't understand, they are not looking up. We have the decimals, right? The one that I was terminating. I gave instances, right? I am coming now.
Oh, you said something before.
Hey, if man is processing many things at a time, should I say calm down? Let me now explain things, right? Calm down now, listen. There are people that don't want here at all. You are talking about another thing. Calm down. I'm forgetting all those people are fresh. So just let's leave it when I'm done. When I'm done, say, you know the answer. Question you want to ask. So that's it, calm down. Now, decimals, right? We have terminating, right? You don't understand what I said about terminating. Who did not understand what I said about terminating? Good. We all understood it. And we have the one that are not terminating. That is, they don't stop at a point, right? They will just continue till whenever. So those ones that continue, they are terminating. We have the ones that have pattern. And the one that don't have a particular what? Pattern. The one that has pattern are called what? Recurring. Because there's a pattern they used to go. We have the one that have single, that are single recurring, where you have 0.3333333 Then we have the one that are not what? Not single. This one I gave you as example now. 1 digit, 2 digit, 3 will come. It will start from here again. 1 4 5 2 6 7. It will start again. 1 4 2 8 5 7. It will start. It will start again. It's recurring. Does this have a pattern?
Yes.
This is a pattern now. That's why it's here. It has a pattern. But the pattern is not single. Unlike this one, 0.3333333. This thing we get to that point. It can never end. Do they have pattern? Both of them have pattern. But this one is single. After single digit, it will repeat again. That's why we call it single what? Recurring. But this one, we count about 5, 6 digits before it will start afresh again. It's not single recurring, but two of them are recurring. They have pattern. Two of us, good. That's why I said they are what? Under what? Recurring. There are ones that don't have a particular pattern. Am I communicating? There are ones that don't have a particular what? Pattern. Remember, terminating decimal have gone. Okay? They have what? Gone. When I say non-recurring, when I say non-recurring, if you watch, non-recurring here and non-recurring here. That's why I put pattern by the side here. This one stops. Is it recurring? Is it recurring? It's not recurring. True or false? This one, they have no pattern. You will not see this thing again, this thing repeating itself. You see entirely mixed up of different numbers till the end. Is it recurring?
No.
Is it recurring? But this is also not recurring. But this is with respect to what? Pattern. That's why I put in bracket non what? Pattern. Am I correct? So if you're not careful, you may confuse non-recurring I said here with non-recurring I mentioned what? Here. This one that stops the point. Okay. Now, this one, this side that have pattern, whether single or non-single, they are rational. Remember, this one is already rational on its own. Terminating is rational on its own. I'm talking about the one that are under continuous that is not what? That is what? Rational. This one here is rational, but this one here is not what? Rational. Pi belongs to this side. Pi belongs to this place. By the time you check the actual value of pi using your calculator, it has no pattern. It's scattered, even though it's inserted from 3.14. It will have no pattern. So pi is an irrational. So this number under this n number that is here is not what? Rational. Things like pi, sword. That's why in your sword in your first year, they will tell you to rationalize a what? A sword. A sword is an irrational number. Things like root 2, root 3, root 7 is irrational. They are not rational. If you want to test, we'll test two of them now. You see what I'm talking about. Who asked me this question that took me back? Is it clear now? Good. Now, I want to put pi here, put here, find their values, root 2, root 2, swords. Then you tell me whether they have pattern or not. If they don't have pattern, they are not what? Rational. They are what? Irrational. So I want to prove to you why I said that pi is not 22/7. And also I also want to tell you why they tell you to assume pi to be what? 22/7. Now here.
You said before we have two types of decimal. There is terminating and recurring decimal. Now I'm going to another different thing.
Which different thing? Now say that different thing.
You said before terminating and recurring.
Okay.
Now I'm still terminating and not terminating. And then I'm not terminating, you are still that recurring. You can change your.
How come that is finished here now?
So it was that's one place earlier you said you have to cut before you said you have to check.
Okay. Are you quarreling? Come down now. You can explain yourself, wouldn't it? Yeah, explain yourself. Let's know what they're saying now. What is it? He is angry. What is we go with you? Explain things. Let's understand your point. Let's understand you. If you don't understand something, humbly explain yourself.
What she's saying is that.
To thank you. What is she saying? Let me hear.
The first one.
Is what? Okay. Wait. I'm coming. You said what?
The first one.
Can you stop? I'm setting up now.
The first one.
I hate this thing you are doing. That is not the right attitude and the right spirit. If you don't understand something, come down and say what you don't understand. Then I will explain. It's wrong. Don't do it in my class again. Okay? If you try it again, I'll stop you from my class. If you don't understand something, calm down and make your point. Let me know what you're saying. You're not bambaka. I call it with anybody. Explain yourself. Then I'll help you out. Please, somebody is now trying to explain your question. Don't listen to you. You're not bambaka here. Oh yeah, talk.
At first, you told us that
Mhm.
under decimal,
Okay.
terminating decimal and recurring decimal.
Terminating.
Decimal and recurring decimal.
Okay, and what? Recurring. Okay,
Then, when explaining it again,
Okay.
that said we have terminating and non-terminating.
They have terminating and non-terminating. Oh, is that what I said?
Yes.
Okay. Now listen carefully. Let me now explain why I said that. Is this non-terminating?
Yes.
Is this not terminating?
Yes.
Huh?
Is it?
If you call it not terminating, it's common sense now. It's common sense. If it's recalling, is it terminating?
No.
It's not terminating now, it continues. That's why I put pattern. I explained it that I attach pattern here. You understand me now?
Yes.
I can remember I explained, I said I attach pattern for a reason. So it doesn't confuse you with the one I put before. Here, yes, it's recurring. It's also what? Non-terminating. So if I choose non-terminating, I committed no crime. But when I put a bracket somewhere, I put no pattern. That is, no pattern. Okay? This thing here is non-recurring. True of us. Now I said with respect to repeating a particular number, maybe after some time repeat it again. Yes, it's recurring, but it has no pattern. You may see to somewhere else, but there's no pattern with which it's going. Am I communicating? So please, whether you say recurring or not terminating, well, it can be terminating, it can be non-terminating. There are some literature you will see they still call it non-terminating. They still call it recurring. Am I communicating? To recur means that it come back again, right? Yes. That one is also recurring, but it has no pattern of recurring. So if it's recurring, it's also non-terminating. Because he's not stopping at a point. It come back again. True of us. But the number continue in that case with no pattern. It's scattered. Is what? Scattered. Now, having explained that, I want to write as please. I don't know, does anybody have a calculator that has wider this thing? Do your phone like this. If your phone has scientific calculator, do it like this. Landscape. So it will have a wide this thing. You press the value of pi there. Let's see. Then also press the value of root. I want to bring out some sorts. Is root 4 a sword? Is root 4 a sword? It's not, right? Because 4 is a perfect what? Square. Good. So that means you understood what you did in sword in your mass 1 getting 1, right? So here is root 2 and root 3. Now let's check. Let's check which of these numbers, the one that is rational, with what I explained. I can say that a rational number in continuous form like this will always have a recurring what? Yes. It will be recurring in a particular what? It will recur in a particular what? Pattern. It can be singly, it can be what? It can be non-single recurring, but it will keep come back again. Now, if you have done your phone like that, what? Check the value of pi. 3 point what?
14159966533589793.
Wait, 7 9 what?
79323846264.
6 2 what? 8 what? 8 3. Let's stop here. No space again. No space again, right? Now check the value of root 2. Fast. 1.20.
4,
1 person. So 1 person. Just 1.1 what?
414.
5.
373.
373.
095. 801.
6.
88.
Okay.
724. 209. 698.
2.
209.
Okay.
698.
698.
078.
Oh, good. You can stop. There's no space again. Okay, I can call that one 08. Go to 78, right? Now, root 3 is what?
1.732.
1.7.
32. 050. 807. 568. 877. 293. 527.
527.
446.
446. 341.
505.
505.
872.
872.
360.
36. Let's stop here. Now let's study these numbers. Look at 22 verse 7. Can you see any pattern there? It has pattern. After this, it repeat again up to the same 6 times. The same 6 digits. It will start from 1 again. The same 6 digits. It start from 1 again. This is what? This shows that 22 verse 7 is a rational number. It's actually continuous rational number. Remember, there's a rational number that are what? Discrete. Remember? Now it's rational numbers. Now look at this pi. Look at pi. Is there any pattern?
No.
It's a pattern. 3.14. 126. There's no pattern. So pi is rational number. Even though it's decimal number. Even though it's not. So why they digits, they have the same digits. So but we put it was another version what? If you put it verse 7, is an irrational. Now, that's all rational number, not the that has sign. It is a irrational one. Now, this is no see is a number. That's rational number. Once you see that sign, you feel it in the okay? This is rational number. You don't know that point. Okay? So basically, this area rational took us most of the time because I know that it's confusing. I know that this will happen, but what you need is to have communication issues. Communication is very powerful. You have like this, you have that idea, but you cannot. But you may become the person's enemy. Even if you for the third of us, right? Are you aware that if you don't communicate, what's the those you came to have enemy, but you communicate to us. Let's say now, let our workers now. You can make us think. Maybe do the arguments to you. Only point could be out. What I'm talking nonsense. No. I won't let you cool down and articulate your point. Make your point, and you are good to go. So we are explaining. Is there anything we have not talked about in numbers? Maybe I think from this phase has stayed with you to different 3 hours. And if one is with you for a long, you keep you start losing interest. So you cannot only time on tomorrow. Besides, I hope you know. Don't know. Somebody that your mind is not what. Listen, please. If there's any other missing the numbers, what? Numerous. To solve those. If I were you, about numbers, I find different and you appreciate what you be doing. I don't think any number. There's some numbers that are rational, but they are what? Continuous. There's some that are discrete, but are rational. You know that, okay? Most of the time, in fact, irrational are continuous. Irrational numbers are always what? Continuous. They're nothing like continuous. They're nothing like discrete irrational number. No. They are always what? Continuous. But rational number can be continuous. It can be what? Discrete. So with this, I believe